Thanks for joining me for this video on the standard form of linear functions and how we find intercepts and use them to graph the function. So we'll take 3 steps here. First, we'll figure out what the standard form is. Then we'll discuss intercepts and explain what they are, and then we'll graph. So the standard form of linear functions is given by the form here that is written sort of in a general form, ax plus by equals c. So in this form, our inputs that are usually the x's and our outputs, which are the y's, are kind of getting the same weight or the same significance. They're both on the same side of the equation, while there's a constant c, which is just a number. A constant is always just a number on the other side of the equation. So we have a times x, so some kind of coefficient a times x, plus b times y equals c. And so in this picture, in this form, we're really looking at the xy plane and not giving either one of the variables, x or y, a more significant weight. We do know that usually in our linear functions we have an independent variable and a dependent variable, but in the standard form this does not stand out. So this is not what we're trying to emphasize. An example of a standard form would be, for instance, 4 times x minus 2 times y equals 20. So we can use that example to look for intercepts and then later graph. So what are the intercepts of a linear function, or really any function? An intercept is where the graph of the function crosses one of the axes. So it can cross the x-axis here, this is the x, or it can cross the y-axis, or it can cross both. But the point is that we try to find where this function intercepts, and that helps us with the graphing. Now, what does that mean that it intercepts an axis? If a line intercepts, say, the x-axis, let's draw some example here. So we see that it intercepts right at that point, which is about 7.5. What does that mean? It means that at that point where x equals 7.5, the y value of this line, right, is exactly 0, because we're actually on the x-axis. We're right on top of it. And when we're on top of the x-axis, our y equals 0. So an X-intercept, which is what I showed here, is derived when we use y equals 0 in our equation. The same thing is true for a y-intercept. Say we're looking at this line here. This one intercepts the y-axis at what looks like 12, or almost 12. So at y equals 12, but our x here, because we're on the y-axis, our x is exactly 0, right? Because every ordered pair we can find the value by going back down to the axes. And so when we're looking at the y-intercept, we have x equals 0. And that is a given. That is what we use in order to find the intercept. So it's not what comes out, but when we have an x-intercept, we take y equals 0, and from this we find x. And when we have a y-intercept, we take x equals 0. This is the given information, okay? And we find the y on this axis where the line intercepts. So let's clean this up a little, and then let's use this example to find our intercepts. Okay, with this example here, 4x minus 2y equals 20. So let's find our intercepts, and then we'll use our intercepts to draw a line, because we know our linear function is a straight line, right? We're only looking at linear functions at this point. So let's look at first we'll look at the X-intercept. So at the X-intercept, we know that y equals 0. So we have 4 times x minus 2 times 0 equals 20, right? We just insert, right, the value for y equals 0 inside this form for the function, which is basically an equation. So 2 times 0 is just 0, and we get 4 times x equals 20. Now we can use the division property of equations to divide both sides by 4, in which case we get x, right, because 4x divided by 4 is just x, equals 20 divided by 4, which is 5. So x equals 5 is our X-intercept, and in that case y equals 0, right? Because we're looking at the X-intercept. So this is our intercept right here. X equals 5 and y equals 0. Okay, let's use a different color to get our Y-intercept. I'm going to erase some of this so that we have some space. Here, let's erase this. And I've erased a little too much, so we have 4x minus 2y equals 20. That was our standard form. And now let's look for the Y-intercept. So when we have a Y-intercept, it means that we're on this line here, so we have to take x equals 0. So we have 4 times 0 minus 2 times y equals 20. 4 times 0 is just 0, right? So let's use again the division property, and this time we will divide by -2, okay? So when we divide -2 by -2, we get 1. So that's y equals 20 divided by -2 is just -10. So y equals -10. So when x equals 0, we get y equals -10. Let's look at that and find it right here. So this point is 0 and -10. So using these 2 points, we now can pass a line between them, right? We can connect them with a line. Between every 2 points, we can draw a single definitive line, and that line will be the graph of our function that we were given in this standard form. So I'll try to pass a nice straight line. Not the greatest, but this line, which goes on from -infinity to infinity, both in x and y, because we did not put any limits on our domain in range. This line is the graph of this sample linear function in a standard form. So we reviewed the standard form of linear functions. We found our intercepts, which are the points where the graph of the function intercepts both axes. We find this by equating x and y to 0. And then we use these 2 points to graph the linear function. So I hope this was helpful, and we will also look at the third form of a linear function, which is the slope and intercept form, and in the next video. But for now, hopefully this was helpful, and I hope to see you next time.